So that's kind of a funny question. X to the 7/3 power is 2187. Okay, let me just get a little more room here. Okay. So what in the world should we do to, you know what our desire is, right? To make it regular x, right? That's what it means to solve an equation, you know. Find normal, regular, everyday x, huh? So how do we turn x to the 7/3 into like normal, regular x? Well, you see we're going to have to put the power, the upside down of that 7/3. It's going to have to be 3/7 power. You know what I mean? So notice we're going to need to come in here and go 7/3 power. No, wait, no. That's the same thing. Upside down, I mean. 3/7 power. And whatever we do to one side, we have no choice but to do the same thing to the other. And do you see how that'll work? That'll make these 3's cancel and these 7's cancel. It'll just be regular x. And the other side, we just do with our calculator. Does that make sense what happened there? So they give you some funky power up there on the x. Just do the upside down power to both sides. Cancels it out. And then just hit the button. Now, let me help you with the calculator. All your calculators are a little different, but generally, you're going to go 2187 to the power. Most calculators have the up arrow or like the X to the Y button as their power button. And then you're going to need to go parentheses. The reason you need parentheses is because you need to make the whole 3/7 be in the power. Do you see how when we have more than one thing in a zone, parentheses are needed? If you have more than one thing in the numerator or denominator or power zone, got to parenthesize it. And then hit equals or enter. And I think, is the answer 27? I did it before the break, 27. All right, so so what's the first thing we're going to do? We're going to get rid of that weird 7/3 power, huh? So power both sides with the upside down, 3/7. And then take it from there. So same thing here. Got some weird old power. We just do the upside down. And whatever you do to one side, you have no choice. Got to do the same thing to both to keep them equal, right? And so these cancel, and that just gives x plus 1, right? Because all the power stuff drops off, and just have x plus 1. And that's going to be, what, 8? And then last step to get x alone, just subtract 1. So x is 7. Good there? Easy enough. All right, I'm going to move on. I think that's an easy time for you. So I'm going to go on to number 4. And absolute value. Remember what we do with absolute value? We actually had this in our review, didn't we? So this will be nice. Have a little experience with it. Even if you didn't master it before, I'm sure it'll help you. When you have the absolute value of the inside equal to some number. Now, this isn't the harder ones. We actually did greater than and less than, huh? So, which we'll see later in the course. And so that'll really help you at that time. We'll see it again, and you've reviewed it. This is just equals, which is the easier kind. Remember that means that like if I told you, hey, I'm thinking of some number. What if I said, hey, I'm thinking of some number. What could it be? And the absolute value of it comes out to be, 10. What could be the absolute value of what number would come out to be 10? Well, what number could I put inside remember, absolute values make everything positive, right? So what could I put in here? There's 2 things I could put in here to make this work, make this true. 10 or negative 10. That makes sense? The inside could be 10 or negative 10, couldn't it? And either way, the absolute value of it would come out to equal 10, wouldn't it? So basically, that's the rule. Whenever you have the absolute value of some inside equals a number, that means that inside could be the positive of the number, or the inside could be the negative. It could be either one, couldn't it? And either way, the absolute value of it will be the positive. So so whenever you see that, you just grab the inside, you say, okay, that inside could be positive 7, or I'll start with the negative. I guess we usually start, it doesn't matter really, but I'll start with the negative. Or the inside could be the positive. So you just do the negative and the positive both. because the inside could be negative 7 or positive 7, and either way, the absolute value will come out 7, won't it? Does that make sense logically, reasonably? As long as this inside is 7 or negative 7, then the absolute value of it will come out regular 7, won't it? So that means that inside could be negative 7 or positive 7, and then we just finish solving from there. So add the 4. And so x is what? Negative 3. And then same thing here, add the 4. And x is 11. So the answers could be negative 3 or 11. Is that good? See how both those answers work, by the way? You know, if I go back up here and I see if x right here is negative 3, then that's going to be negative 3 minus 4, negative 7, and the absolute value will be 7, won't it? See how that works perfectly? Or the other answer, 11, if I put 11 right there for x, then that'll be 11 minus 4, 7, and the absolute value, again, is just 7. See how those are the two answers that work. All right, so I think you know that, and you're pretty comfortable with that. Let's do 1 or 2, just to make sure you're still good. So absolute value, 2x minus 5 equals 1. So try that. Just pull out that inside, like pulling the snail out of the shell. Giving you a creepy analogy there, sorry. But just pull it out, equal to 1 or negative 1 or positive 1. The inside could be negative 1 or positive 1. Either way, if that inside is negative 1 or positive 1, either way, the absolute value will come out 1. Come out regular 1. Okay, so I grab that inside and say, inside you can be negative 1 or inside you can be positive 1. Either way, the absolute value will be coming out regular 1. So then I just solve each of those. So add the 5. And over here also add the 5. And so then these cancel. 2x is what? 4. Over here these cancel. 2x is 6. And then divide by 2, divide by 2. And x is 2 or x is 3. So the answers are 2 or 3, huh? Both would work. You go back and check them for fun. Put in a 2 there. 2 times 2 is 4 minus 5. Negative 1. Absolute value comes out positive 1. It's working, isn't it? Or if you put in the 3. 2 times 3 is 6 minus 5. 1. Absolute value is 1, yeah. Those are the answers that work. Is that good? Okay, so let's jump to number 7. And they've got a little more going on there. 8 minus 3, absolute value 2x plus 6 equal to 2. So really, let me add to the process then. So for absolute value equals problem, step 1 is to get the absolute value alone. So first off, we have to get rid of that 8 and get rid of that 3. And by the way, we cannot subtract them right now and say that's 5. You can't go 8 minus 3 and say it's 5. Why not? Because that 3 is multiplied by something. Remember the order of operations? You can't do it. You know what it's like? I could probably help more if I say it like this. What if you had 8 minus 3x? Could you make that? Could you subtract those and make it 5x? No, you know you couldn't. Why? Because they're unlike terms, huh? That 3 has an x with it and the 8 doesn't. Whereas if the 8 had an x, then you could do it, huh? 8x minus 3x, yeah, that'd be 5x. Well, we're actually just going to get rid of the stuff instead. But yeah, you're thinking right, Faith. Basically, the 3 has an absolute value with it, and the 8 does not. So they're unlike terms in that bigger sense. So anyway, I'm just saying what you can't do. I'm probably over-talking what you can't do. You can't do that. So instead, we're just going to get rid of all this stuff. So let's start with the 8. Here's the equal sign. How do we get rid of the 8? Just subtract 8. Yeah, so rather than distribute or anything, we just want rid of the stuff. So we get rid of that first off, then we get minus 3. Absolute value 2x plus 6 is minus 6. And now how do we get rid of the minus? Do I add 3? Yeah, I divide it. Why do I divide the minus 3 rather than add 3 on the next step? because it's multiplied. Now, that minus 3, good, is right up against that wall of the absolute value. It's times, isn't it? So you divide it off. Boom, like that. And so, and then that comes out, what does that come out to be? Minus 6 divided by minus 3, plus 2. Two negatives make positive there. So all of that was step number 1. Get the absolute. See how the absolute value is alone now? It's all there is on the left side. You know what I mean? There's nothing outside of the absolute value. So that's step 1. Get him alone. And now you know step 2, right? Now pull the snail out of the shell, right? Step 2. Then you go inside equals the negative number, or inside equals the positive. So that comes after we get the absolute value alone. So finish it up, pull the inside out, equal to the negative 2 or the positive 2. So take the inside and say, okay, the inside, the 2x plus 6 is negative 2, the negative of the number, or the inside is the positive. And then we need to solve for x. So subtract 6 from both. And so this is negative 8. And over here we subtract 6 from both. And this is negative 4. Last step, divide by 2. And so x is what? Negative 4. And over here, x is negative 2, huh? So the answers are negative 4, comma negative 2. So it's the same as the last couple. We just have to do the step 1 where we got the absolute value alone. So first get it alone and then pull the snail right out of the shell, equal the negative number and positive number. All right, question. On to number 8. So number 8 is going to have a square root. Okay, now they're going to give us some tricky square roots, especially in the end of the section. So what do you do when you have a square root problem? Solving, so we're learning how to solve different kinds of equations. Solving a square root equation, what do you do? Step number 1 is to, let's just say for now, I'll add to it as we need, but I'll just say second power, now let me just write it. Just parentheses, yeah, just do that. Just put parentheses and second power both sides. Because again, remember roots and 2 powers are opposites of each other, like antidotes? So if you swallow a poison, what are you supposed to do? We'll go to the hospital and they'll give you the antidote. And you swallow that and it neutralizes it in your stomach. That's kind of what we're doing with roots and 2 powers. They're opposites. So if we have a problem that has a root somewhere, we're going to 2 power it. And if we have a problem with a 2 power, we're going to root it. Because they're opposites of each other. They'll cancel each other out. So that's pretty much always the plan. So if I see this root, I just go, oh, it's got a root. So let me bring it down here. I'm just going to go ahead and 2 power both sides. And what will happen? On the left side, those guys will neutralize each other, like that acid and the poison in the end. I just tell you that like it's a rule, like Mr. Heron says. That'll work. Let me connect it logically to what you already know. Remember what we've learned about like root of 7, root of 7. What does that equal? Didn't we talk about roots? And what does that equal? Remember roots are a 2-for-1 deal? And so 2 7s inside is 1 plain 7 outside, huh? 2 for 1, 2 in, 1 out, right? You know that rule for roots, right? So anytime you have 2 numbers in a root, 2 of the same, 1 comes out, no longer in a root. It made it out. Well, do you see that's exactly what happens here? Why am I saying they cancel? Well, because when you put a 2 on there, it means 2 of them. Doesn't it really mean that? At first, anyway. I'm not going to show that every time. But wouldn't you agree that's what it really means? When you put a 2, it means 2 of them. Let me go back and, not just do the quick cancel, but give you the reason. I think it'll stick in your mind better if I tell you the reason. The reason the 2 power cancels it is because at first it means 2 of them, right? We all agree with that. And then what do you do when you have 2 of the same thing in a root? 1 comes out. You got 2x minus 6 is in, 1 comes out. So look at that. There it is. No more root, no more 2 power. That's why we just say cancel, because that means 2 in and 1 comes out. All right, and the other side, 1 squared. This is 1, huh? This is 1 times 1. right? This just means 1 times 1. So it's just 1. And so then that's easy. Now that you got rid of the root, it's an easy equation, isn't it? Just add the 6. So x is 7. So you got a root, put a 2 power on both sides. That'll cancel it out. All right. Let's go. Number 9 is back here. It's a word problem, so I want to show it to you. Here it is. Here's number 9. It's given this equation. Let me write that a little bigger for you. So number 9 is v equals square root of 20L. It's interesting. The police use this formula to estimate the speed of a car, v in miles per hour, based on the length L in feet of its skid marks when suddenly braking on a dry asphalt road. At the scene of an accident, a police officer measures the car's skid marks to be 209 feet. Approximately how fast was the car traveling? Round your answer nearest 10. All right, so that formula, it connects how long the skid mark is with how fast the car was going. So, they're only giving me one number, 209. So the question is, do I plug that? I'm going to plug it into the formula. Do I plug in the 209 for the V or the L? Yeah, it's L. It's the length of the skid mark. How do we know? It says right here, length L in feet of the skid mark. And they said this skid mark is 209. So that's going to plug in for L. So V is the square root of 20 times 209. So you just simply plug it in and then take out your handy-dandy calculator and just find out what the square root of that is. I have no idea. 20 times 209 in the square root. I'm getting 64.6529, on and on it goes. They want me to round it to the 10th, which is 1 decimal place. Remember how rounding works? They want me to give one place past the decimal. So you circle the place you're going to stop at, and you look 1 to the right of there. If the 1 just to the right is 5 or more, you go up, huh? So it's going to be 64.7 miles per hour. Number 10 has that little triangle for us there. Can you see that thing? They're giving us 9 on the bottom, x and 17. I can make those a little bigger. So this is 9x and 17. And notice it's a right triangle. So anyway, anybody remember the formula that you're supposed to use when you got a right triangle? What is it? A squared plus b squared is c squared. Yeah, it's called, what's it called? Pythagorean Theorem. Yeah, Pythagorean Theorem. So you can use that anytime you've got a right triangle. See that 9? So it's for any right triangle. So we have a 90-degree angle, a right angle. So any right triangle, yeah. Now, when you use that formula, it's pretty easy to use. The order on the A and the B don't matter. You can switch them. It doesn't matter. As long as you get the C right. You got to get that one right. How do you know which one's supposed to be the C? Which side?
Isn't like X? The X is always...
No, they can put the X anywhere. So we can't track it by the X.
The C is the...
Lajenae, do you know? Yeah. Yes, that longest side. Anybody know what that longest side's called? Hypotenuse. Good memory. I'm not going to quiz you on all these names, but yeah, it's the hypotenuse. It's the longest side. Yeah, it makes sense, huh? Because those add up to be it, so it's got to be bigger. Right, yeah. So the C is this side. This side's the C. The A and the B, you can switch them around, doesn't matter. But you got to make sure you get that side as the longest side. The other two, either order, you could go x squared plus 9 squared or 9 squared plus x squared. It doesn't matter at all. As long as the 17 is the C. Because see how he's the longest side in the triangle? So they squared add up to be him. He's longer than them, right? He's the longest side. He's called the hypotenuse. I'll write the word for you. He's the hypotenuse. So C has got to be the longest side, technically called the hypotenuse. Okay, so then we just use our calculator. 9 squared is just 81. 17 squared, is it 289? I think I remember it, right? Yeah, 289, yeah. Okay, good so far. So I just squared the x, squared the 9, squared the 17. 17 times 17, 9 times 9, that's all I'm doing there. Now we're trying to solve for x. What do we do, remember, when we have x squared and then just numbers? We don't have to factor or do any of that fancy stuff. Yeah, just get that x squared alone and then root it, and it'll tear off that 2. Remember that? It's a quick way to go if you just have x squared in numbers. Yeah, so just get rid of this 81 so that the x squared can be alone. And so we're going to get x squared is 208. I'll bring it over here. So x squared is 208. And what do we do now to get rid of that 2 power? What's the opposite of a 2 power? A root. They're opposites of each other, aren't they? They undo each other. And there we go. Now, normally, when you put a roof on a house, I always say go up and down the ladder, right? Plus or minus. But hold on. I mean, technically, yeah, that's true. But look, this is a real-life triangle. See, x is one side of a real-life triangle here. So it can't be negative, can it? You can't see, I measured that triangle. It was -3. It was the weirdest thing. No, there's no such thing, right? So we don't do the negative. So you understand, math is made up to describe things that are real. Sometimes math goes beyond reality. When it does, we ignore it. There's no chance x is negative here, is there? So we ignore that. So, and do they just want a decimal? Oh no, they want exact value, not a decimal. So we got to break that 208 down. So use your calculator. 2 times, what is it, 104? 2 times 52. Oh, it's got a little further to go. So here, I gotta move it up. I'm out of room. So yeah, so bring it up here. X squared is 208. And then root it. Root it. Okay, so now break down that 208 again. 2 times 104, 2 times 52, 2 times 26, 2 times 13. So this becomes the root of 2, 2, 2, 2, and a 13. 4 2's. You see them all here? 4 2's and a 13, right? That was all the stuff that couldn't break down any further. Those are the pieces of a 208. Remember what square roots do? They're a 2-for-1 deal. So we grab them. We say 2 2's inside, 1 2 out, 2 2's inside, 1 2 out. So it's 4 root 13. That's the answer they want. 4 root 13 on that one. You simplified that root of 208. Game plan when we have square roots. So solving square root. What do? Step 1, get the root alone. Step 2, parenthesis 2 power, parenthesis 2 power. Because you get in the theme, these are just opposites, aren't they? When we have a root, we 2 power. If we have a 2 power, we root. They just undo each other. They're just opposites of each other. So, but first you've got to isolate the thing, right? So first, we've done this several times today, huh? So first you have to isolate that root, get that root alone, and then do the parenthesis 2 power, parenthesis 2 power on both sides. Root alone, what's my first step? Add that 9, perfect. Add that 9, and those cancel out like that. And that's 16. So there's step 1. Okay. And then, so we get the root alone. And now what do we do on step 2? Parenthesis 2 power, parenthesis 2 power, right? See how we do that? We isolate the root, and then we 2 power both sides, and that'll cancel out the root, won't it? So the root cancels the 2 power. They're just opposites of each other. Other side, I'd use my calculator. 256?
Yeah.
256. And then what's our last step to get x alone? Add that 18 to both sides, yeah. And then, whatever that is, 274. There we go. Back to 12, and 12 is another word problem. I don't think it'll be hard. It's another just plug in, I think. Yeah, so they give you another formula. V equals the square root of 2.4 r. It's the maximum safe speed in miles per hour at which a car can travel on a curved road with radius of curvature r in feet. So notice they can tell like how fast you can go on a road so you don't skid out on a corner. It's actually a formula that'll do. Now, of course, it really depends on the car and the tires and if you study physics, the coefficient of friction. It's called the kinetic coefficient of friction. So it depends on a lot of things. So this is a general formula that would work for the general car on the general road surface. But basically, that's how they figure out these kind of things. So that's a connection based on the radius of the curve. The radius of a circle is how far from the middle to the edge. So the radius of the circular portion and the velocity of the car. You shouldn't go any faster than that so you don't skid out around the corner. All right, so a highway crew measures the radius of curvature at an exit ramp on a highway as, what was that, 740? I can't read that. I went over the top of it. I think it's 740. Yeah, 740 feet. What's the maximum safe speed? So that's how they figure out, speed limits and curves. So, the question, I'm just going to take that 740 and basically plug it into that little formula. Now, does it plug in for V or R?
For R.
Yeah, because it's radius, huh? So it plugs in for R. So V is the square root of 2.4 times 740. And they just want a decimal. So just hit the buttons on your calculator. So do that same square root thing we did. And I'm getting, 42.14. And they say to round down, so we'll go down to 42. Makes sense to round down, doesn't it? Because you don't want to go over 42. If the safest speed is 42.1, you don't want to go 43. That wouldn't be safe. That's why they're saying you round down. 42 would be the safe speed. Yeah.
On my calculator, it's 10 that is 1,770.
Tricky. Put it back here where we get some room. Okay, so 13 has got 3 plus 2 square root. X plus 6 is not a 9, yeah. And so again, remember, solving a square root, step 1, get the root alone, isolate it. Step 2, parenthesis 2 power both sides, huh? So can you do that again? So here's the equal sign, the wall, the left side, right side. So go ahead and get that root alone, and then 2 power both sides. Okay, so what do we do to isolate that root? Yeah, subtract that 3. And that'll be gone. And we have 2 root x plus 6 is 6. He's almost alone. What do we do next to get the root alone? Yeah, we divide by that 2, right? Not subtract 2 because it's times. Yeah, perfect. Divide by the 2. And so then we get the root alone. Okay, now, so that was all step 1. Get the root alone. He's alone. And so now what do we do? Once we've got the root isolated, then how do we get the root to go away? Yeah, we 2 power both sides, huh? Because that's the opposite of a root. Just isolate and do the opposite. Cancels out, and you get x plus 6, and 3 squared is 9. Is that good? And then we just subtract 6, don't we? So x is 3. It's getting easier. Just isolate and do the opposite, huh? Isolate and do the opposite. Okay, they're going to push us a little bit. Now that you're comfortable with that, that's what math always does, huh? And they push it to a new level. They're going to push it a little harder. Not a lot harder, but it's going to put together 2 things you already know. All right, so remember the game plan for solving roots. get it alone in 2. I'm not going to write it out again. You get it alone in your 2 power. Well, is the root already alone on this one? It is, huh? The root is already alone. So I'm just going to jump right into the 2 power. Now, here's the trick when you 2 power. Here's a common mistake people make. They'll go 2 power, 2 power, 2 power. No, you can't, not quite. You can't do it that way. You have to go parenthesis 1 2 power on the left and parenthesis 1 2 power on the right. That's what's correct to do. So just, parenthesis 2 power, parenthesis 2 power. For the whole left side, whole right side. Bless you.
Thank you.
And now, some tricky stuff's going to happen. On one side, it's going to be easy, left side. Right side's going to be more tricky. Right, on the left side, these just cancel each other out. That's, no big surprise, nothing new there. Root and a 2 power are the opposite, of course. So that's just x plus 11. No more root, no more 2 power. They eliminated each other, didn't they? They're the poison and the antidote. But on the right side, the 2 power is not going to cancel out, is it? Because there's no root over there to cancel it out. Well, then what do? What does the 2 power tell you to do? Write 2 of them, huh? And then we got to multiply that out. Do you see why there was not 2 of them on the left, but there are 2 of them on the right? Because on the left, the 2 was canceled out by the root, huh? So he didn't get to do his 2 thing. But on the right, he does his 2 thing. So then you guys know how to multiply out that right side. So let's do that. So you just go, first to both, second to both. Remember that whole thing? So this is all stuff you know. It's just all kind of like all in one problem at once. Careful with your signs there. You getting that okay? Okay, now what do? Well, remember how we can gather these 2 are like terms? So what is minus x in the middle going to be? Minus 2x, because it's really 1x and 1x. It's minus 2x. Good to there. Now, this is where it's easy to just kind of go, what is going on? You feel like you've done something wrong, because the problem's getting worse, Well, no, we're doing well. What have we done so far? We got rid of the root. See how there's no more root symbol anywhere? So we are making headway. It's just not an easy question. How are you supposed to know what to do now? Well, what you want to be thinking, we're going to do some combining, but specifically, this guy should be sending you a signal. Whenever you see, so keep 2 things really clear in your mind. In the beginning, we saw a root, and so we thought, 2 power. And now we're seeing an x squared. Remember, and we wrote out earlier what the plan, we just had a whole section on solving x squared. What's the plan? Step 1, get a 0. Step 2, you can try to factor if you want, or you can use the negative b plus or minus the square root of b squared minus 4ac all over 2a. That's what you need to do when x squared shows up. So you got to have those 2 processes down really cold, because they'll intermingle with each other now in these harder ones. This is where we're college algebra now, where it's harder. They're kind of putting together several things. But you know all this stuff, right? So when you see that x squared, you think, okay, go into a whole new game plan. When x squared rears his ugly head, you go, get a 0. And get a 0 where? Get a 0, let me add to the story a little bit now. Get a 0 opposite side of x squared. Get a 0 on the opposite side of x squared. So x squared's over here. That means make this left side become 0. Does that make sense? Make the other side 0. So, okay, how am I going to make the other side 0? Well, I got to do the opposite of both those guys, don't I? That'll make it go bye-bye and 0, won't it? But whatever I do to one side, got to do the minus x and minus 11 to the other side also, don't I? Do you see where I'm going? As soon as I see x squared, I think, I know the x squared plan. Get a 0, try to factor, or use the quadratic formula. So I'm going into that whole new game plan now. Getting a 0 on the opposite side. We've done some of these before. We're just not used to seeing this halfway through a problem like this. It's kind of weird, huh? They normally start out with x squared, but this one appeared halfway through. So x squared. So minus 2x and minus 1x. Negative 3x. And positive 1 minus 11? Negative 10. So step 1, get a 0. We did. Step 2, I bet you could factor that pretty easy. And you don't have to use the quadratic formula. You could. You could always do the negative b plus or minus. But if it's an easy factoring one, that'll be quicker for you. Either way will work, but I think factoring would probably be quicker. Can you factor that real quick? Okay, we good. Cranking along. So this is going to be x is in the front. Yeah, what multiplies to be 10? 5 times 2. And remember the sign in the middle goes in the bigger. Minus 5 plus 2 makes the minus 3 in the middle. They multiply to be negative 10. And now what do we do when we have, what's our next step? Two things are timesing to be 0? So many steps, no? Two things are timesing to be 0, so either one could be 0, right? If two things are timesing to be 0. So we take that x minus 5 alone to be 0, or the x plus 2 alone to be 0. Then we just solve each of those. So add 5 to both. And this cancels. X is 5. Subtract 2 from both. This cancels. Negative 2. We got our two answers. 5 and negative 2. A lot of work there. And if you type those two answers in with a comma, it'll tell you no. Because there's one more step. I'm sorry, I feel like I need to apologize. This is just messy, hard to, it's college algebra. One more step. With a square root problem, you have to check your answers. The method can bring in false answers. Even though we haven't messed up, the method has the ability to bring in faulty answers. It's kind of a tricky situation. So let me put down here, let me write a special note for you. Any problem that starts with a root, you must check your answers. You must check your answers because they can bring in a false. The method we use can actually bring in a false answer. It's the best method we got. It's all we got. But it can bring in a false answer. It's like if you got a friend that lies to you every now and then. Right? That's what this method's like. Right? And it's your friend. You care about him. You hang out with him. But, what I mean by check the answers. You got to take this 5, and then you got to take this negative 2, and you got to plug them into the original. What original? This, the very first step. So let's do it. So check. So what was the first thing? Square root. So the original equation was square root of x plus 11 equals x minus 1. So I've got and I'm going to do it over here. We have two numbers we have to check. So first off, I'm going to check the 5. So I'm going to check the x is 5. So I'm going to put in 5 there, see if it works. Square root of 5 plus 11, does it equal 5 minus 1? Square root of 16, does that equal 4? Yeah, 4 equals 4. That's true. So that one checks. That answer's a keeper. That answer's good. But the other one will not. Check. X equals, what's the other one? Negative 2? Yeah, it won't work. Put in negative 2 there and there. You'll get negative 2 plus 11. Negative 2 minus 1. Square root of 9, that's negative 3. Square root of 9 is regular 3. That doesn't equal negative 3. No. So the only true answer is 5. So after all that work, that's the answer to that problem. Just the 5. Only the 5 checks. So you have to remember, any problem that starts with a root, you have to check it. You have to check your answers. Does that make sense? Any problem that starts with a root, you have to check your answers. It's just when they start with a root right in the beginning. When you get your final answer, you have to check because it could be false. Is that good? The check's pretty easy. You can really just do it on your calculator. The check. Just plug in the numbers in your calculator. It's really pretty quick. You just got to remember to do it. When we get to the exam, I'll remind you and I'll say, hey, when I hand you the exam, next time, look at it. Any problem with the root, just circle them and check your answers. Remember to check your answers, So, okay. So that's number 14. How are we doing? So 15 and 16 are going to be kind of more of the same. Yeah, okay. So 15 So 15, let's check out 15. So that one says square root of m plus 2 equals the square root of m plus 13. Yeah, that's a tough one. Okay. So what are we going to do to get rid of those roots? 2 power, yeah. 2 powers are opposite of roots, right? So now, so you go parenthesis 2 power, parenthesis 2 power, right? Now, on one of the sides, the right side, it's going to be a simple deal because the root and the 2 power just cancel, and it's just m plus 13. No more root, no more 2 power. It's all good. But now on the other side, you might think, well, on the other side, won't it just do the same thing, just cancel out that root? Well, if there was just a root, yeah, if it was just a root, or if that 2 was multiplied. Do you know what I mean? If it was 2 times the root of m, yeah, then it would just square the 2, remove the root, it would be 4 plain m. Does that make sense? But it's not. It's not. What is it? It's got the terrible thing in algebra. It's got what? It's got the plus sign. Remember, pluses and minuses make everything hard? They always do. So instead of just like cancel, cancel like that, you have to actually write 2 of them. Like that. You got to write 2 of them, and then you got to go boom, boom. You see, because they're 2 separate things. Pluses and minuses, I'm always beating the drum that they're Costco package deals, right? And they are, but that also means they're 2 separate things, which have been glued together by Costco or by the plus or minus. So because they're 2 things, you got to multiply 2 things. You have to do it. So we have to multiply 2 things. Okay, so how's that going to happen? What's root of m times root of m? 1 plain m. Remember, two whatever's in a root sends 1 out. 2 for 1. Beautiful. Good. I'm glad you're remembering that, getting the hang of that. So root of m times root of m is plain m. Root of m times 2. Well, the 2 will just go to the front, and the m will stay inside. Remember, different worlds. Outsiders stay outside. Insiders stay inside. And then next, the 2 will go to both. So it's another 2 root m, and 2 times 2 is 4. Okay. Now we should gather some like terms right here in the middle. These guys are going to combine, right? So m plus 2 root m and 2 root m? 4 root m, yeah. Okay. Now what? This is where it gets hard with these more, this is college algebra, more advanced algebra equations like this that have lots of different things in them. It's to kind of, it'll really have you stay focused on the different methods. Mainly what I mean is, if you see a root, you know what to do. If you see a 2 power, you know what to write. Those are the 2 main strategies we've gone over in this section. So if you saw an m squared, we don't have an m squared right now. But if you did see an m squared, what's the game plan? Get a 0, try to factor, or use the quadratic formula, right? So know that. So if m squared ever pops up, just go right into those steps. And what if you see a root m, or any root, isolate it, and 2 power? Well, we do see. That's exactly what we see right there. So he's yelling out to us, get me alone and 2 power, right? So that's where we should be driving next. When we see that root, we go, get that thing alone and 2 power. That's what we always do when a root shows up on the scene, huh? Okay, so how do we get that thing alone? Yeah, subtract that m and subtract that 4. Whatever you do to one side, do to the other. So gonzo, huh? So 4 root m. These cancel. 13 minus 4 is 9. Right, that's what we always do. Let me write it up here for you. When you've got a root, get the root alone and parenthesis 2 power. That's always the game plan. Even if you're halfway through a problem and a root shows up, you go into that game plan. So now it's almost alone. What do we got to do to finish getting it alone? divide by the 4. So the root of m is 9/4. So we got it alone right there. And so step 2, parenthesis 2 power, parenthesis 2 power, right? Get the root alone, 2 power. And it'll just tear it off, right? They're antidotes. So m equals, and now the other side, there's no root or anything, so we just square the 9, square the 4 on our calculator, right? 9 times 9, 4 times 4, just 81 over 16. 81 over 16. Now, do we need to check that one? Sorta. Yeah, I mean, I wouldn't. I would type, in the homework, I would type in the answer, and it's right. 99% of the time, it's all good. Technically, yeah. Like I said, anytime you have a root, you're supposed to check. I don't want to be doing it all the time, though. This one will check. You could use your so technically, yes. You should use your calculator, plug that in on the first step, and make sure it works. Most of the time, it will. And it will work. So the easy way would be to type that into your calculator, type it in right here, and hit the button. Figure out the left side in your calculator, figure out the right side in the calculator. If they're the same, they will be. Then it's good. That is the answer. All right. That was probably the hardest one in the section.